Are you ready to dive deeper into arrays, or should I say the ultimate containers of chaos? They are like the overachievers of data structures, always ready to store, organize, and confuse us at the same time. Hi everyone, welcome back to CodeWithPk, where learning about DSA is as fun as trying to explain code to a grandma. I'm your host Ryan, and today we are unlocking the next level of arrays. If part 1 was the appeal teaser, this is the buffet. Get your place ready because we are serving up multi-dimensional arrays, operation, and life-saving tips to avoid those out-of-bounds nightmares. So, grab your coffee, put on your coding cap, and let's turn these brackets into brilliance. So, let's go started. Application advantages and disadvantages of array. So, we have come into our part 2 of our array. So, let's learn about application advantages and disadvantages of array. So like I've told you into my next previous video, like array series will be gone to 1 week, okay, and one more video has been came. This is a part 2 of arrays. So in today's video we are tackling about application advantages and disadvantages. So let's talk about it. Array is a linear data structure that is a collection of data elements of same types. Arrays are stored in contiguous memory location. It is a one static data structure with a fixed size, like array data structure. So this 1, 2, 4, 10, 5, 15, 3. What is these are? These are the array elements. Okay, these are the array elements, and this 0, 1, 2, 3, 4, 5. What is this? This is a one array index. What? This is the array index. This one array data structure. Okay. Table of content. Applications of array data structure, advantages of array data structure, disadvantages of array data structure. In this page, we are learning about it. Application of array data structure. Arrays mainly have advantages like random access and catchy friend lines or over other data structure that make them useful. Below are some applications of arrays, like first, storing and accessing data. Means arrays store elements in a specific order and allow constant time access to any element. Number 2, searching. If the data in array is sorted, we can search an item in O log n time. We can also find floor, ceiling, KTH smallest, KTH largest, and etc. efficiently. Metrics. Two-dimensional arrays are used for metrics in computations like graph algorithms and image processing. Implementing other data structures. Arrays are used as the underlying data structure for implementing stacks and queues. Dynamic programming. Dynamic programming algorithms often use arrays to store intermediate results of subproblems in order to solve a larger problem. Data buffers. Arrays serve as data buffers and queues temporarily as storing incoming data like network, packets, file streams, and database results before processing. Now, let me tell you the advantages of array data structure. I told you about the applications of data structure. So now let me tell you the advantages. Then I told you the disadvantages. First, the advantages is efficient and fast access. Mean that arrays allows direct and efficient access to any element in the collection with constant access time as the data is stored in contiguous memory location. Number 2, memory efficiency. Arrays store elements in contiguous memory and it allowing efficient allocation in a single block and reducing memory fragmentation. Now, versatility. Arrays can be used to store a wide range of data types, including integers, floating point numbers, characters, and even complex data structures such as objects and pointers. Number 4 advantage is compatibility and with hardware. Now, the array data structure is compatible with most hardware architectures, making it a versatile tool for programming in a wide range of environments. Now, Disadvantages. Now, let me tell you the disadvantages of array data structure. First, fixed size. Arrays have a fixed size set at creation. Expanding an array requires and it creates a new one and copying element which is time consuming and memory intensive. Number two, memory allocation issues. If you're allocating large arrays can cause memory exhaustion, leading to crashes, especially on systems with limited resources. Number two, insertion and deletion challenges. Like in this, adding, removing elements requires shifting subsequent elements, making these operations inefficient. Then, number fourth, limited data type support. Arrays support only elements of the same type, limiting their use with complex data types. Now, last, lack of flexibility. What it can do is fix a size and limited type support make arrays less adaptable than structures like linked lists or trees. Okay, so our this chapter has been ended by the name of applications, advantages and disadvantages of array. I told you about the application data structures and I told you about the advantages and disadvantages of arrays in this chapter. So let's move toward under the next chapter, and the next chapter is on about what is our next chapter. In the next chapter we are learning about the why array data structure is needed. So in the next chapter we are learning why array data structure is needed. Why? So let's talk about it. Assume there is a one class of 5 students. Assume that, okay, you have a class, assume there is a class of 5 students. Let me come on to the notepad, and here is a one class. Here is one class. Now assume that there is a one class of 5 student class with class 5 students. 5. Okay. And if you have to keep records of their marks, like records of marks like 98% in the examination, then we can do this by declaring 5 variables individually and keep tracking of records. In C++, Java, Python 3, C#, and JavaScript. This one example, and this one example in the C++, here you can see it. This one example. So let's run this example. Let's copy this and let me come on my Google and let me search here my channel. Sorry, let me search here Replit. So now in this tutorial we are using the Replit. Okay. When I open the Replit, I create a one REPL. Okay, it is. Let me come on to the home and let me create a one C++ file. And in that file, I'm pasting this. So when I run it, so now it take a little bit loading. Okay. It is giving me the error. Unused variable v1. Okay, this variable has been not used, that's why it is giving me error, because I do not print this variable. Means using the echo, we do not print our v1, v2, v3, v4, v5 variable. So that's why it is giving me this type of one error. Okay. Now, anyways, but what if the number of students becomes very large? But what if the number of students become very large, like 5, not 30? So what we can do? It will be challenging to manipulate and maintain the data. What it means is that we can use normal variables like v1, v2, v3 when we have a small number of objects, but if we want to store a large number of instances, it becomes difficult to manage them with a normal variables. Now, the idea of an array is to represent many instances in one variable. Like in this example, like here with the one diagram, in this diagram, this is one example of the need of array. This one example of the multiple variables to store in each value. Like here we create a one v1 variable in which we write 10, then we create a one v2 variable in which we write 20, then we create a one more variable v3 in which we write 30, then 40, then 50. So in this example we are doing like this, okay? Like here you can see it. And it gives in the single array to store all values like 10, 20, 30, 40 and 50. So this is one idea of an array where is to represent many instances in only in one variable. Okay, this is an idea. Advantages of array data structure: efficient access to elements. Arrays provide direct and efficient access to an element in a collection, and in accessing an element in an array is an O1 operation, meaning that the time required to access an element is constant and does not depend on the size of the array. Number 2, fast data retrieval. Arrays allow for fast data retrieval because the data is stored in contiguous memory location. This means that the data can be accessed quickly and efficiently without the need for complex data structures or algorithms. Memory efficiency. Arrays are the memory efficient way of storing data because the elements of an array are stored in contiguous memory locations. The size of the array is known at compile time. This means that the memory can allocate it for the entire array in a one block, reducing memory fragmentation. Versatility. Arrays can be used to store a wide range of data types, including integers, floating point numbers, characters, and even complex data structures such as objects and pointers. Now, easy to implement. Arrays are easy to implement and understand, making them an ideal choice for beginners learning computer programming. Now, compatibility with hardware. The array data structure is compatible with most hardware architectures, making it a versatile tool for programming in a wide range of environments. Now, this chapter has been also be ended by the name of what is the name? I forgot. Let me tell you what is the name. And this chapter has been ended by the array data structures is needed. So, I have told you why array data structure is needed. So, let's move to our next chapter, and our next chapter is on about different ways of accessing array elements in C++. So, in this chapter, we are doing some coding also. So let's come on this chapter and let's talk about different ways of accessing array elements in the C++. In this article, two unique and different ways of accessing element from array rather than the conventional means ARR in the square brackets I expressions are discussed below, like using pointer ARR plus 1 using a little manipulation I underscore AR square brackets ARR for using arrays and the reason behind that. When a C++ program is compiled, a symbol table is generated simultaneously. It is formed to store the corresponding values of the address of all the variables used in the program. Let us consider a C++ program and see what will symbol table for the corresponding program. This one example of the C++ program for above concept. This one code we have written in the C++. So now the output will become 5. Let me show you. Here you can see the value of A is 5 and address it is giving me E0x7FFDBAE4C6D4. So now when I run more times, it will give me a different address. So when I run more times, it will give me a different address. Here you can see it is giving me different address. When I am running, so it give me different address. So you can see it. Only focus on the address. Okay. Here you can see it is giving me different address. So what is that? This one symbol table for the program above will be look like this. Okay. This is one symbol table for the program will look like this. Okay, and when you are running at 100 time, it is changing the address. So you can see it is changing the address of a value. Here you can see it like it is changing the address of a value. Now, so from the symbol table, it can be seen that every variable is assigned an address. Therefore, when the array is initialized, it is also gets some address in the table and array that is stored in a form of a pointer pointing towards the first element. Now, below example is one another simplest way of accessing array element in C++. Here you can see it. So, if the number is equals to 11, now let me show you. Now, let me copy it. So now the number is equals to 11, like 12, 13, 14, 15, 16. Give you this type of an output. Let me show you. Now it gives you the output. The number is equals to 11, like 12, 13, 14, 15, 16. Addition of numbers is equals to 81, and average of number is 13.5. Here you can see it. It gives me like this. Here you can see it. In this example, it int a square bracket 10 gets stored like star a, which points to the first element. Okay, this points to a first element, and this points to a second element. Similarly, we can have the last element pointed by a star a plus n minus 1. We have n minus 1 as arrays in C++ have zero base indexing. Using this concept, let us discuss the first method of accessing the arrays. Using the concept of pointers, here you can see this one below is the one C++ program to implement the above concept. There is one C++ program to implement the concept. Okay, there is one C++ program. So let's run this program. Let me copy this program and let me paste it. And when I run this program, so it is giving me the error. It is giving me give me the output values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why it give me the values till 10? Because in the default in the int I equals to 0, I write 10. If I write here 100, and in the second line of code we write 100, so it give me the values till 100. Okay, sorry, why did not give me? It is tag mismatching terminated. Okay, let me come on it here and 100, and then let me give me 100, and now perfect. So now you can see it is giving me the number till 100. Okay, so like that you can print the numbers. Okay, so like that. So now let's come down. Values is coming like this. Fun method. As observed, like you have observed, an array can be used as star ARR. Therefore, it can be said that as no, star p plus 1 is exactly the same as star 1 plus p. Therefore, star ERR plus I in above code can also be written as star I plus ARR, and basically star ARR plus I means A in the square brackets implying star I plus ARR can also be written as I square bracket A. Now, below some CSS program to implement the above concept. Okay, so let's run this, and here you can see in this chapter we are doing a many coding in C++, and you are thinking why I'm running the code in C++, why I'm not running in the Java, Python, and like these type of languages, Python, Java, C#, and these. Why? Because C++ has a fast runtime program. Okay, means that when you give the input to the C++, so it give you the output. C++ give you the output in only in 1 second. But when you run it in the Python, then the Python will be give you the answer in like 5 to 6 seconds. But C++ is a very fast run program. It give you the answer in only in 1 second. Let me show you. There's one more code here. You can see it is showing you. So let's run this code. So when I paste this code and when I run it, so it give me the output here you can see it give me the output in 1 second. And now it give me 10. Why it give me 10? Because I write figure 10. Okay, all the way here I write 10. If I write 100, should give me a 100 number, 1 till 100. Okay, and if I write here 200, so it give me 200. Let me show you. So like this. Now let me run it. So it give me the number still 200. Here you can see it give me the number still 200. Now like that, like this you can do it very easily as. Okay, below 7 CS program to implement the above concept. We implement our above concept in C++. Here you can see it. Now output values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the output will become like this. And my output has been coming like 200. Why? Because I write in my array I write 200, so that's why it give me output in the 200. So I hope your concept will be clear about it. So our this chapter has been also be ended by the name of, let's see the name of this topic. And in this chapter we do a many coding, and in this chapter we talk about what is the how to get the numbers. How to get the numbers means that in this topic we see different ways of accessing array elements in C++. So let's move toward our one more topic, and our another topic is about why does accessing an array element take 1 time. Okay, so let's talk about it. An array is our linear data structure. What is the array? Array is our linear data structure. In an array, the operation is to fetch a value, take a constant time, for example 0, 1. Let's just see why it's so. Why the complexity of fetching value is 0, 1? As arrays are allocated contiguously in memory, fetching a value via an index of the array is an automatic operation. All the automatic operations are done in constant time, for example 0 and 1. Now, explanation. In an array, we have the memory address of index 0, base address by adding the product of the index number of the value to be fetched. And the size of one element, for example, int size is 4 bytes with the base address. We have the address of that index value. We don't have to iterate through the array, so it's done in 0, 1. Like this one, address of ith index equals to base address plus offset equals to address of 0th index plus I multiplied by size of one element. And this one example, this one diagram means that in this diagram, here we define an index, memory blocks and memory address. So this 0, 1, 2, 3, 4, 5, this one index. What is that? This is the index. Okay, these are the index. Let me do the weight. Okay, and these are the memory blocks like 8, 8, 6 and 7, 13, 8, 9. This is one memory block. And this one memory address like 100, 104, 108, 112, 116, 120 and 124 and 120 and 132 and 134, and it's going on, gone. Okay, now address of I equals to address of index 0 plus I multiplied by size of one element. Address of index 0 equals to 108 plus 4 multiplied by 4 equals to 124. This is one memory allocation in array. This is one diagram of a memory allocation in array. In array means a square bracket equals to a6, 7, 13, 18 and 8 and 9. To fetch the value at index 4, we need the memory address where the value of that index is stored, and the address can be obtained by doing an arithmetic operation. For example, address of value at index 4 equals to address of index 0's value plus 4 multiplied by size of int equals to 108 plus 4 multiplied by 4 bytes. Address of value at index 4 equals to 124. A is in the square bracket 4. Value at address 124 equals to 8. For more details, please refer design and analysis of algorithms. So this chapter has been also be ended by the name of why we does accessing an array element take 0, 1 time. So I know this chapter has been smaller, but let's move to our next chapter. And our next chapter is on about, in the next chapter we are learning about inserting elements in an array and array operations. So in this chapter we are learning about it. So let's start. In this post we look into inserting operation in an array. For example, how to insert into array, such as insert element at the beginning of array. In number 2, insert an element at a given position in an array. Number 3, insert element at the end of the array. Insert element at the beginning of an array. Inserting an element at the beginning of an array involves shifting all exiting elements one position to the right to create an empty space for the new element at index 0. For example, if you give this type of input like ARR and the square bracket, then you write equals to 10, 20, 30, 40. ELE equals to 50. The output will become 50, 10, 20, 30, 40. And then if you write input ARR and then square bracket and then you write equals to square bracket, then ELE equals to 20. Then the output will become only 20. To know more about implementation, please refer insert element at the beginning of an array. Insert element at a given position in an array. Inserting an element at a given position in an array involves shifting the elements from the specified position onward one index to the right to make an empty space for the new element. This operation ensures that the other of the exiting elements is preserved while placing in the new element at a desired index. After shifting the elements, the new element is inserted at the target position. For example, this one example, if you give this type of an input like ARR square bracket equal to 10, 20, 30, 40 and then you write comma POS equals to 2, ELE equals to 50. The output will become 10, 50, 20, 30, 40. Okay, and if we write ARR square bracket equals to square bracket POS equals to 1 and ELE equals to 20, the output will become 20. Then if you write ARR square bracket equals to in the square bracket if you write 20, 10, 20, 30, 40 and comma POS is equals to 5 then ELE is equal to 50. The output will become 10, 20, 30, 40, 50. Okay. To more about the implementation, please refer insert element at a given position in an array. Insert element at the end of an array. Inserting element at the end of this array involves adding the new element to the last available index of the array. Inserting an element at the end of the array takes constant time provided there is enough space in the array to add the new element. Okay. And this one input, if you give this type of an input like ARR square bracket then equals to in the square bracket you write 10, 20, 30, 40 and ELE is equals to 50. The output will become 10, 20, 30, 40, 50. And then if you give this type of input like ARR square bracket then equals to square bracket like ELE equals to 20, the output will become only 20. To more about implementation, please refer insert element at the end of the array. Okay, so let's come up related post, searching elements in an array, array operation, deleting elements in an array, array operations. So this chapter that will also be handled very easily as. So now from the next part we learn many things about arrays. So please get ready for the part 3 of the arrays. So get ready for it. So this video has been ended very successfully as. So I hope you enjoyed this video. If you enjoyed, so please like this video, share, friend, and subscribe to my channel. And don't forget to all notifications. I will also never miss about these type of videos on our DSA data structure and algorithms. So we'll talk about the arrays and this is our part 2 and please wait the part 3. The part 3 will become very soon. Okay, and then come on to my channel by the name of CodeWithPk like all the people know, I know. So first of all go to the CodeWithPk channels. So when you click onto my channel, so open my channel and then when you open my channel click onto the videos and I uploaded one video, so go and see it. And successfully as you complete, please complete my 9,100 subscriber in my channel and then come on to the playlist. And when you come on to the playlist, come on to the data structure playlist and then first of all bookmark my playlist and access my playlist and see my all the videos on our data structure. Okay, and why you are not liking my video, why you are not sharing my videos, so go and share my videos. And how to share it, click on the share, copy and then paste it anywhere you share it. And you also share it in your WhatsApp, Twitter, Facebook, LinkedIn, and then Reddit, VK, OK, Pinterest, Blogger, and then Tumblr, Mix, and Goo. So go and share my all the videos and you will be also share it in the Kick. Okay, so go and share it. And in this video we do a coding first time in data structure and algorithm, means first time in this video. So I hope you enjoy this video. So now let me give the out of this video in the big screen. So let's move toward under the big screen and let's give the out of this very beautiful video, very protected means very good video. So now let's give the out of this video. That's wrap for arrays part 1. Congratulations, you have just taken your first steps into the array universe. Don't worry if it felt a bit like untangling headphone wire. Trust me, it gets easier if you enjoy this video. Smash that like button like you are trying to debug a stubborn error. Don't forget to subscribe and hit the bell icon so you don't miss part 2, where we will take arrays to the next level. See you there, and until then, keep coding, keep crushing. goosebumps. So now, for today, goodbye.